Good day once again, students, and welcome to the chemistry class. Adejobi Munininola Ajibi Chemistry is my name once again. We are going to be taking a few questions in practical chemistry. In your practical chemistry at Waec and Neco, there are 3 questions you will be taking. Question 1 is simply titration or quantitative analysis. Question 2 is qualitative analysis. That's where you deal with identification of cations and anions. And question 3 is general chemistry. So the questions we're going to be treating in this lesson or series of lessons are some sample questions in question 3 and their answers. So the first question I have here is, state the difference in the physical properties used to separate mixtures using the following separation techniques. State the difference in the physical properties used to separate mixtures using the following separation techniques. A. Fractional distillation. B. Simple distillation. C. Fractional crystallization. D. Filtration. E. Separation funnel method. Now, for fractional distillation, the physical property used is closeness in the boiling points of the components of the mixture. Simple distillation, physical property used is the wide difference in boiling points of the components of the mixture. For fractional crystallization, the physical property is the difference in the solubility of the substances in solution. And then for filtration, the physical property has to do with difference in the particle size or particle sizes of the components of the mixture. And for separation funnel method, that is actually used to separate 2 different liquids, the physical property has to do with difference in density of the liquids. Second question, a solid chemical sample T decomposes on heating to give a white residue U and carbon 4 oxide gas. On addition of water to U, P, which is often used to identify carbon 4 oxide gas in the laboratory, is produced. State the identity of T, U, and P. That question is a very simple one. It says a substance T decomposes on heating to give a white residue U and carbon 4 oxide gas. Any substance that will liberate carbon 4 oxide gas when it is heated must either be a trioxocarbonate 4 or a hydrogen trioxocarbonate 4. But because we have been told that the carbon 4 oxide, the residue rather, is added to water to obtain U, which is used to identify carbon 4 oxide in the laboratory, that automatically tells you that that residue is no other substance but calcium oxide. If you add calcium oxide to carbon 4 oxide, you get calcium trioxocarbonate 4. So T is calcium trioxocarbonate 4, U is calcium oxide, and then P that we have been told is used to test for carbon 4 oxide is no other substance but calcium hydroxide. When calcium hydroxide is dissolved in water, it gives us what we call lime water in chemistry. Quickly, let's take the third question. What is the color of K2Cr2O7? That is potassium heptaoxodichromate 6. And then list 5 gases that can change its color. The answers are as follows. 1. K2Cr2O7 is either orange or yellow in color. And 5 gases that changes its color are, number 1, sulfur 4 oxide, that is SO2 gas. Number 2, hydrogen sulfide gas, that is H2S. Number 3, alkene. A typical example is ethene, that is C2H4. And number 5, alkynes. A typical example is ethine, that is C2H2. I've given you 4. Because the question says you should give 5, you can give one more example of an alkene and one more example of an alkyne. We'll come back later. You are welcome back after the short break. So let's take the first question for this segment. It goes thus: name a suitable device for the following. A. Filling acid into a burette. B. Adding indicator to a solution during titration. C. Storage of silver trioxonitrate 5 solution. D. Production of gas in small or intermittent quantities. And E. Heating copper metal. And maybe we should add another one: separation of a mixture of liquid paraffin and water. For the first one, a funnel of appropriate size is used to fill acid into a burette. The second one, dropping pipette is used to add indicator to a solution during titration. Number C, amber colored bottle or brown colored bottle is used for the storage of silver trioxonitrate 5 solution. Number 4, Kipps apparatus is used for the production of gas or gases in small or intermittent quantities. Number 5, Bunsen burner is used to heat a strip of copper metal. And number 6, a separating funnel is used to separate a mixture of liquid paraffin and water. So let's go to the next question. How would you dehydrate sugar and ethanol? How would you dehydrate sugar and ethanol? For the two of them, you use the same substance. You simply add concentrated tetraoxosulfate 6 acid. When concentrated tetraoxosulfate 6 acid is added to sugar, a black mass of carbon, charcoal, is obtained. I need to sound a note of warning here. Never try the use of any concentrated acid without the supervision of your teacher. And number 2, when ethanol is treated with concentrated tetraoxosulfate 6 acid, ethane gas is produced. Third question. Explain why it is required to moisten a strip of litmus paper while testing for the acidity or alkalinity of a gas. Let me take that again. Explain why it is required to moisten a strip of litmus paper while testing for the acidity or alkalinity of a gas. The answer is water is required to ionize the chemical content of the litmus, whether blue or red, so that the ions present in it can react with the ions present in the acid or base. The next question, why is it required to acidify sample solutions with dilute hydrochloric acid while carrying out confirmatory tests for tetraoxosulfate 6 ions? Let me take that again. Why is it required to acidify sample solutions with dilute hydrochloric acid while carrying out confirmatory tests for tetraoxosulfate 6 ions? The answer is this. In order to remove interfering ions present in the sample. The interfering ions present in such a sample are 2. It could be trioxocarbonate 4 ions or trioxosulfate 4 ions. The dilute HCl will remove these interfering ions so that your test sample will be free to be tested for tetraoxosulfate 6 ions. Now, the last question for this segment, list 5 gases that must not be prepared in the open laboratory. 5 gases that must not be prepared in the open laboratory. 1, chlorine gas. 2, carbon 2 oxide gas, that's also called carbon monoxide. 3, hydrogen sulfide gas. 4, hydrogen chloride gas. And 5, nitrogen 4 oxide gas. This is because all these gases are either poisonous or they have very, very bad and offensive odor. Thank you. Welcome back. Let's take the first question for this segment. State one air pollutant that causes the following: blood poisoning, acid rain, and blackening of walls of buildings. For the first one, blood poisoning. This can be caused by two gases: carbon 2 oxide, also called carbon monoxide, but please don't write carbon monoxide in chemistry. The IUPAC name is carbon 2 oxide. And then the second one, carbon 4 oxide. That is also generally called by the layman carbon dioxide. Now, for acid rain, the following gases causes acid rain: sulfur 4 oxide, that is your SO2 gas; carbon 4 oxide, that's your CO2 gas; and hydrogen sulfide gas, that is H2S. And for the blackening of walls, only one substance causes that is soot, that's powdered carbon. When you burn a substance, that black powder that you get is what causes blackening of walls. Question 2. Express the phenomenon illustrated by A. Spreading of the smell of hydrogen sulfide or any gas with a perceivable odor in the laboratory or in an environment. The answer to that is diffusion. B. Existence of atoms of the same element having different mass numbers. The phenomenon for that is isotopy. And C. Movement of particles through a semi-permeable membrane from a region of high concentration to that of lower concentration until an equilibrium is established. The phenomenon for that is osmosis. And D. Irregular or random movement of smoke particles in air. Again, the phenomenon for that is what we call Brownian movement in chemistry. The next question. State 3 reasons why air is considered to be a mixture. Let me take that again. State 3 reasons why air is considered to be a mixture. The answers are as follows. Number 1, the components of air can be easily separated. Number 2, each component of air still retain its individual properties in spite of the fact that they have been mixed together. Number 3, air cannot be represented by a single chemical formula. And number 4, there is no heat change when components of air are mixed under ordinary conditions. The next question. Suggest a means of storage for A salt which fumes in air. That salt can be stored in a desiccator inside which a drying agent has been placed. Examples of drying agent that can be used in a desiccator are calcium oxide and calcium chloride. B. A compound which readily decomposes when exposed to light. That kind of a substance should be stored in an amber colored bottle. And C. A flammable gas. Such a gas should be stored in what we call a pressurized gas cylinder. In fact, that is essentially what you have in the cooking gas that is being used at home or used to perform experiments in the laboratory. They are all flammable gases, and so they have been stored in pressurized gas cylinders. And D, a metal which reacts explosively with water. Such a metal should be stored under liquid paraffin. Remember, in all this series of lessons for today, we have been treating questions or sample questions at Waec or Neco exams that could be administered in question 3 of your practical exam. I did say at the beginning that question 3 is essentially test of your knowledge of general chemistry. I wish you the very best, and I pray that you will remember all these things if you possibly come in contact with them in your exam. God bless you.